Hi, good evening, guys. Welcome to NextGen IT courses. We will wait just 2-3 minutes more and then we will start the session.
Okay, sir.
Hi, good evening, everyone. So we have our trainer also with us, Mr. Azad. So this is the session regarding the Palo Alto Firewall. Hi, good evening, Azad sir.
Hi Sachin, good evening.
So sir, we can take just 2-3 minutes or 5 minutes recap for yesterday's session, and then
Mhm.
we can continue with today's class.
Okay, all right, no problem. Can I get started or should I wait for people to join in if
Just
there are?
2 or 3 minutes. At exactly 9:05, we can start session, sir.
All right, so let me wait till 9:05. I'll be on mute. Yeah, thank you.
Yes, sir. Thank you. So yes, we can start the session, sir. Continue.
All right. Can I get started, Sachin?
Yes, sir, please.
All right. Okay. All right. So thanks, guys, for joining. I think uh, I'm assuming all 14, in fact, 12 of you guys, excluding myself and Sachin, were part of yesterday's session. Is there anyone joining new today? Out of the 12 guys that I see there, any new joinees for today,
I'm joining
apart from yesterday's session?
for the first time.
Oh, okay. All
Yeah,
right.
I'm the first time.
Okay, so I see a couple of people. So let me give a recap on what we saw yesterday. I hope you guys can see my screen. So with respect to yesterday's session, we have spoken about um, firewall with respect to what is a firewall in general, and we have also took it up to a point where we discussed about the data sheet, the hardware devices that your Palo Alto might have, and we have also listed down a few features of your Palo Alto firewall. We did not go in depth of any feature, or we did not even define them. So the agenda yesterday was pretty simple. We just took a few Q&A with respect to what would be a job role after you get trained in this product, in this Palo Alto NextGen firewall. And we've also discussed about some technical or design level questions with respect to the audience on what they had with respect to the product and out of that as well. So once after the Q&A was done, as I mentioned, we have spoken about the Palo Alto firewall hardware types. So with respect to what model devices we have and how do you basically procure a firewall, what are all the aspects you might have to look into, right? So post which we listed down a few features of the firewall and why do we call them as a next gen device, right? And also we spoke about what is a stateful firewall, and we gave a dashboard overview. So with respect to how you take the management access to the device, your firewall, how do you configure a management interface, and how do you access the firewall in the first place when it is out of the box? And after accessing the device, what options do you have? So we just went on a glance about the firewall's options with respect to what tabs do you have and what is it used for, and what's the significance of each tab. So this was the overall agenda for yesterday. So for today, we will be talking about just one topic, which probably might be very important, which is your Palo Alto's packet fee, right? Okay, so with respect to the Palo Alto firewall, we will today be talking about how does it process the packet from the time it gets it till the time it releases it out to the next device, right? What exactly happens within the firewall is what exactly we're going to see today. So for which I will be taking the help of the official documentation. So if you just search for the life of the packet in Palo Alto, you will find the knowledge base of your Palo Alto networks, which will talk about exactly what we will be discussing today. So I just will be using this flow chart for me to better explain the packet flow, right? All right. Okay, so getting started with the packet flow, I would like you to know that your firewall is basically going to have about 5 stages before it releases the packet out, or before it takes it in and releases the data out, right? So with respect to the 5 stages, the first and the last stage is pretty straightforward. That's exactly what any layer 3 device would do. The ingress and an egress stage. So ingress stage is something that a stage where your firewall receives the packet, right? And egress stage is something that it does before releasing the packet out to the next device. In between, whatever happens in the firewall is what your security or next-gen firewall feature that takes in, or that happens within the firewall. So basically, you have session setup stage, or otherwise called a slow path. You have fast path and application identification and content inspection, right? So there are about 6 stages, if not 5. So you have ingress and egress. You have firewall session setup stage or slow path, fast path, app ID, and content inspection. All right. So let's try to discuss each of them one by one. So with respect to stage, you have the firewall will receive the packet in, right? So let me take my pen. Give me a second for me to write them or pen them down. Okay. So with respect to the ingress stage, the firewall will first receive the packet. It will extract some basic information like any layer 3 device would do, like your layer 2 information, MAC address, layer 3, which is your IP address, source and destination IP, and the protocol and port number. Yeah. Along with that, it will also identify what is the interface the traffic is coming in and what exact zone it belongs to. So I haven't spoken about what a zone is. So there are definitions that you need to know about zones, but for now, just understand that like devices. So there could be three networks or three VLANs coming from inside. So these are all like devices. Like for example, you have Corp LAN network, you have Wi-Fi network, and you have um, a lab network, right? So these are the three VLANs which normally users would use in a company, right? So all these three VLANs can be categorized into or named as inside zone or corp zone or corporate zone. So it's basically a zone is nothing but a name given to a group of interfaces which does probably the same job. So a user connecting to a cable network, or if he is connecting to a Wi-Fi network, both of them are expected to have same access, right? So when you are in an organization, if you connect to Wi-Fi or if you connect to a LAN cable network, you are expected to have same level of access because it's the same user who is accessing it, right? With respect to which Active Directory domain you belong to or your username, you are supposed to have same access, right? So it's ideal for you to group them into a same zone rather than putting them in different zone, right? Similarly, when a like when a VLAN when a couple of VLANs are doing the same job or connecting a same number of users, same type of users on your firewall, they can be grouped as a single zone called as inside zone or corporate zone. So basically a name given to different or number of interfaces on your firewall. So that's your zone. So basically your firewall will extract your layer 2, layer 3 and layer 4 information, ingress, interface and zone, right? And it will do fragmentation if applicable. So fragmentation probably might be required if your device, your firewall, if it understands that the next device, maybe it's a router that is supposed to forward the traffic to, if it cannot accept all the data at once. So let's say 500 MB of data is supposed to be sent. If the device cannot accept all the data at once, the firewall at layer 4 can fragment the data. So it can divide the data into segments, right? So that's what we are talking about here. Yeah? IP fragment reassembly if applicable. So basically, when there is a device who is sending the data to the firewall, if it has fragmented the data on layer 4, the firewall to club the data into a complete 500 MB of file, it should reassemble the fragmented data. So the data here probably might have come in as 100 MB chunks of 5, total of 500 MB. So the firewall is supposed to do a reassembly if the data have been fragmented earlier, right? That's exactly what we're doing here, right? If applicable, the data will be reassembled if it has been fragmented. Okay, so with respect to that, the firewall will send the data down with all the information it has collected. And if there is any error notified, so if you remember, on all your layer 2, layer 3, and layer 4, you will have a CRC or fragment offset check, which means it will check for errors on each of your layers by default, right? Each of your layers header will have a specific field which will talk about error checking. So the error checking happens here. If there is any error identified, the firewall will be discarding the packet. If not, if it will forward it down, right? Then the firewall will check if the traffic that is coming in is applicable for inspection or not. On what basis will it decide if the firewall can inspect the traffic or not? If I go back to this, if I go back to this website, if I just come down to this table, I have my packet type and interface mode, right? So I don't need you to know virtual wire or tap right now because we haven't spoken about it, but you already know what is a layer 3 and layer 2 and the packet type. So the packet type is something which is unicast or multicast or a broadcast packet. And the interface operational mode would be layer 3 or layer 2. There are other modes like virtual wire or tap, which we will talk about later. But for example, if you consider layer 3 and layer 2 with respect to the packet type, which is unicast or broadcast or multicast, you know that layer 3 will not entertain broadcast. A router will not entertain broadcast, or any layer 3 device will drop the broadcast packet, right? So if it is a broadcast packet and if it's a layer 3 broadcast, the device would drop it because your firewall is again a layer 3 device, right? Like a router, your firewall also drops your broadcast packet if it's layer 3. Right? If it's a layer 2 broadcast, it could be ARP based packet. It could be ARP packet. So it could only forward the packet. It will not inspect, right? So if it is an ARP, the firewall will only forward or flood the packet, right? So it's basically talking about ARP here. Similarly, if it's a unicast layer 3, it will inspect and forward. It's the normal type of packet that we might see in most of our cases, IPv4 unicast and layer 3. Layer 3 unicast, then we are expecting the firewall to inspect and forward the traffic. If it's a layer 2 unicast, it is expected to inspect and forward. So likewise, depending upon what type of packet and what is the interface mode, the firewall will decide whether the traffic has to be only forwarded or dropped or inspect and forward, right? So this is where you will be able to identify whether what is the firewall, how does the firewall take a call with respect to whether the firewall inspection is applicable or not. All right. So finally, before it gets out of the ingress stage, it will verify if it is an IPsec based packet. If the packet is an IPsec based, you know that there is a inbuilt original IP header inside of IPsec packet, which is supposed to be inspected. So the tunnel will be decrypted by the firewall and the same process happens again, because as you know, you have you basically will have your IP header, the original IP header, which is the original source and destination IP of your computers or servers, on top of which you will have IPsec header. You will have the tunnel IP information. So you have to decrypt or de-encapsulate this to see what's your original IP header, for which you can then do a analysis of extracting layer 2, layer 3, layer 4 information, check for errors, and then check if the application firewall inspection is applicable or not. Right? So if it is an IPsec based packet, the firewall will decrypt it, get to the inside header of inside IP header of the IPsec packet, and then it will do the processing again. Right? Okay. So once this is completed, then it moves on to the session setup stage, where it will see if the session is already available. So if, for example, this is a firewall, this is a PC, and this will be your server that you are working on. All right. Let's say this PC has already accessed this server probably about 30 minutes ago. The firewall would have processed this packet, allowed the traffic to the server, and then the response might have come back. So which means the firewall would have maintained a session on the session table with respect to what's the source IP, destination IP, port number, application, protocol, etc. So it will have the information of the connection that was established earlier, which is 30 minutes ago. Hence, the firewall doesn't have to create a new session for this traffic, because the same IP contacted the same server for the same port and protocol and application just 30 minutes back, and the firewall already have made a note of the session information on the session table. So since the session is already available, the firewall will utilize the same session. Okay. So if in case it's a new packet, if there is no session available for that IP, source IP to destination IP, the firewall will consider that as a new packet. If it is so, the firewall will move to session setup stage. So if the session is already available, this session setup stage will be skipped. So the purpose of this session setup stage or slow path is just to create a session for the traffic that is coming in, right? If the session is already available, if the session match found is yes, then the firewall will continue with the fast path, right? If there is no session available for this traffic, then it will work towards the slow path to set up a session and install a session, right? The purpose of slow path is just to get relevant information and create a session. And then it will go on to do the same thing that would have been done if the session was already found, right? So consider that there is a new session, and the firewall is supposed to process this and then create a new session and install a new session. So the first thing it would do is do a forwarding lookup, which is check the routing table, identify what's the egress interface and what's the egress zone. So what your routing table would have in general, it will have what's the destination network and what is the exit interface, right? So that's exactly what will be looked up here. Basically, your firewall will take a look at your routing table. It will identify what's the egress interface to get out to reach the destination IP and what's the zone, right, from the layer 3 routing table, right? So once after the egress interface is identified, the firewall will then look up for the NAT policy. It will check for this specific traffic, is there a NAT policy created, and if it is applicable or not, right? And there is a special case here. If the traffic is for destination NAT, if we are NATing the destination of the traffic, then it will do a forwarding lookup once more for a specific reason. Okay, let me take you to the whiteboard. blackboard before I get past this for you to understand this clearly. So just read through this clearly. So first thing it does is check the routing table, identify the exit interface, and the zone. Second thing, it just checks for the NAT applicability, if this traffic is applicable for NAT or not, right? And a special case here is if it's a destination NAT, then do a forwarding lookup yet again to get the final egress interface or zone. So why is it doing it? Let's discuss. So consider the same example. You have a PC, you have a firewall, you have a server. Okay, let me take for example, this is a server. This is a server. This is sitting in the DMZ zone, and your firewall is here, and this is internet, and you have somewhere a user from internet. Yeah. So let's say this user wants to hit this server. Obviously, when he's coming from internet, he will be hitting the public IP that will be assigned for this specific server and will get NATed, and then he'll be hitting the private IP of the server. Right? This is how your NAT works. So this being a destination NAT traffic. So since you're NATing the destination here, the public IP is going to be NATed to your private IP of the server when an internet user accesses it. Since you're NATing the destination side of the traffic here, your security policy that you write. So I have not spoken about the security policy, but then just for the context of this explanation, understand that any traffic through the firewall is not allowed by default. The firewall is supposed to have a policy explicitly defined for it to allow any traffic that is passing through the firewall. An exception is if it is from a different zone. If it is from a same zone, for example, let's say two servers on a DMZ zone, they can communicate by default without a policy. But if it is coming from a zone and going to another zone, the source is from a zone and destination is to another zone, then you need to have a policy for the traffic to be allowed, right? In that means, if you write a security policy for this specific traffic, a user coming from outside, that is internet, trying to hit the public IP of your firewall for accessing the server, which will then get added to the private IP of the server, you need to have a security policy because the traffic is coming in from internet based or internet facing zone, and it's going to get into TMZ zone, right? So different zones. So exactly, you should have a policy defined. So this is where the trick lies, where when you're writing the security policy, especially for the destination section, the firewall is expecting you to write down the destination section of the policy in such a way that you got to write them with respect to pre-NAT IP and post-NAT zone. If it is a destination NAT traffic, right? So consider this, pre-NAT IP is nothing but before NAT, what was your IP for the destination? It's public IP, right? After NAT, it becomes a private IP, but before it gets NATed, the destination is your public IP. So it should be a public IP on your security policy. And post-NAT zone is after the IP gets NATed, what is the corresponding zone? So when the public IP gets NATed, it becomes a private IP. And where does that IP lie? It lies in DMZ zone. So you got to be having DMZ as your zone in your destination. So public IP as your IP and DMZ as your zone for your destination NAT security policy. So because of this change, this is the reason why your destination NAT, if it's a destination NAT specific traffic, then you got to do your diligence to check the firewall has to do the diligence to check the routing table again to figure out what is the final egress interface and zone, right? So that's the exact purpose of why we do it. I hope this is clear. So after doing the ingress stage, the firewall checks if the session is applicable, session match is found. If not, it starts its slow path where it checks for its routing table for identifying the interface and zone, and then NAT, and we discussed about why destination NAT is a special case. And then finally, it looks for the security policy. So right now, the firewall has not identified the exact application that the user is trying to access. So if it's Facebook, or if it is Instagram, or if it is Flipkart, because when the user first accesses the website, he is going to be hitting an SSL application, because it's an HTTPS website, HTTPS facebook.com, or HTTPS Instagram, or HTTPS Flipkart or Amazon. Initially, the application will be identified as what? SSL. And then when he finally hits the page, it will use this signatures, application level signatures, to identify what is the exact application that the user is using, which is over here, right? So at this low path stage where the session itself is not created, there is no way that the firewall will know what's the application that the user is trying to hit. So while checking the security policy lookup here, your application will be kept as any. And the other parameters like IP address, your zone with respect to port numbers, service ports, or everything will be checked across your security policy, and it will see if it is allowed. If it is allowed, then the creation of session will happen. If not, discard, right? So let's say the policy is allowing everything except your application, because it is considered as any in this case, because we haven't identified the application yet, right? So considering that your security policy is matching, the firewall will create a session, and then it will move along to the fast path where it will now implement the NAT. So earlier in the slow path, it would have just did a lookup, and this is where it will implement the NAT, meaning it will do the NAT to translate the IP address from public to private or private to public, wherever the traffic lies, right? And also it checks if the session is in active state. So how does it verify if it is in active state? Let's say, for example, you are talking about a TCP packet, and let's say we are in a stage where the handshake is happening. So you know that the first and foremost thing in a handshake is a SYN packet, then a SYNAC, and finally your acknowledgement. So this is supposed to be the flow, and post which your data transfer will happen. Let's say a SYN packet is coming through, and immediately you see a data packet being sent. So there is a break in sequence here, and the firewall will then identify the session is not in active state. It will immediately discard the packet. So anything of this sort is not entertained by the firewall. It is going to keep the active state of the session always throughout the traffic. So it is going to check the active state of the session as well. It is going to do the NAT if applicable, right? Finally, after this, the firewall is going to check for the decryption policy. So if you're not aware, the firewall is also capable of decrypting your SSL traffic. If you say SSL, it's an encrypted traffic, right? HTTPS or SSH traffic. So in both of them are going to work with certificates, and they are encrypted. So the firewall is capable of decrypting them if it is asked to, right? We should have a policy across a specific traffic saying that for this source and this destination, you decrypt this SSL traffic. If we have a policy specified, then the firewall is capable of inspection. It's capable of decrypting that specific traffic and inspecting it, after decryption, right? So if that anything of that sort is configured on the firewall for decryption, then the firewall will do that. Okay. So once after the decryption is checked, the firewall will then now verify this across the application identification and content inspection. So what happens with application ID? It will first check if there is any custom application being defined. App override policy is nothing but if a specific application is created by the company itself, they will create the application, the port number that they have used for the application on the firewall, and create a custom application for themselves, right, with a custom port number or everything. If anything of that sort is a match, then it will check. If not, it will go for pattern-based application identification. So what happens here is that if it is an HTTP application, for example, the first packet that you expect out of an HTTP application is a GET request, HTTP GET, right? And then put data is your next packet. So similarly, there is a format or there is a structure in which each and every protocol works, right? So there's a pattern in which everything works. So based on the pattern, the application will be identified by the firewall, right? So how exactly it identifies it? There is no data that is available for us to view, but they've just told that they will be identifying the application based on the pattern. So finally, once the application is identified, the security policy lookup will happen again, because over here, when you did a security policy lookup, the firewall would have kept your application as any. So here, after identifying the application, it will do another security policy lookup. If it is a match, then it does the content inspection. If not, it discards the packet. So what happens in content inspection here? It basically checks if there is any application change that is taking place. If there is any application change, it will again go for the security policy lookup. So on what basis the application might change? As I said, initially when your user is doing a HTTPS request, maybe facebook.com, or if he is trying to do it for Amazon, or if he's trying to access any other application, initially the application would be identified as what? SSL, because he is accessing HTTPS website. So only after the user logs into a specific website, he will be, the firewall will be notified that it is a different application, which is Facebook or whatever it is. So in that way, if there is any application change that has happened because of this type of access, the firewall will then just give me a second. Yeah. The firewall will then look up for this application, the end application across the security policy, and then it will see if it is allowed or not. If there is no change in application, it will then go on to apply the security profile action. So basically, what does it do here? Based on the antivirus, anti-malware, URL filtering profile, or file blocking, all the next-gen security profile will be applied here, and the necessary action. So with respect to if it has identified a virus on a specific file download that the user is attempting to, it will send alert, or it will discard the packet, or whatever action that we're taking across that specific action that the user is doing, it will be applied over here, right? And finally, if you might have done any SSL decryption here, the re-encryption happens at this specific stage of content inspection, right? So once after your application is identified, your content inspection, your security profile is checked across, your firewall will now move on to egress stage or forwarding stage, where it will use the ingress interface to get the forwarding domain and do routing or switching or virtual layer forwarding. So basically, it will do what your routing table says, right? Packet forwarding process. And then it'll check across any QoS specific QoS specific configuration being applied on the interface, egress interface. Let's say this is the firewall and this is your exit interface. If there is any QoS specifically mentioned or QoS configuration specifically mentioned here with respect to whether this specific traffic, let's say voice traffic or your Teams traffic, is supposed to have more bandwidth given to that. So according to the QoS configuration, it will be applied. And also, like you did your reassembly of fragmentation that might have happened earlier before you have received this packet, before the firewall might have received the packet. So at this stage, if you remember, we did a reassembly of the fragmented packet if applicable. So if any device behind the firewall, might have fragmented the data and sent it to you, you got to reassemble it. Likewise, if the firewall got to fragment it because the other device next to the firewall cannot receive the whole bunch of data, the firewall will do the fragmentation. right? And finally, as you know, here we have done a decryption if it's a tunnel specific, IPsec specific traffic or SSL traffic. The re-encryption would be done here, and then the egress stage will be again processed to send the packet outside, right? So technically, if you check this, it's a 6-stage process. Normally, ingress and egress stage is something that every device would have. One difference is decrypting the traffic for IPsec or SSL VPN tunnel packet, right? That's something that your router might not do. Apart from that, you can break this down into with slow path and without slow path. So if the session is already there, it is going to skip the slow path. If the session is not available, it's going to include the slow path to create a session, right? So in the session fast path, it's basically going to do the NAT and do the SSL decryption if required, and then move on to application identification and content inspection, right? So this is how the firewall processes your packet before it sends it out. This is what it does basically to process your packet. So any questions to anyone with respect to this?
So regarding each path, right, you told me that forward a firewall session setup, right, slow path,
Mm-hmm.
where the NAT would be uh, the NAT if the destination NAT is configured.
Mm-hmm.
So you mentioned that pre-NAT and the post-NAT policy should be there. Only then that inspection, the process would be established, right?
No, because the firewall expects the security policy to be in that way. So if you see, this was the example I was giving, right? So if you
Yeah.
take the example, good that I did not delete it. Oh,
Control Z undo.
I think it will not happen. Okay, it's okay. Let me just write it down again. So you have your PC. Give me a second. I think it's not happening. Okay, it's a whiteboard this time, right? Okay, so you have your PC. You have your, okay, let me not take a PC, but a server, because you have your server and your firewall, ISP, and you have a user sitting in internet zone. So the user
Mm,
will be hitting your firewall to access your server. You will be hitting the public IP that is assigned for the server, and
mm,
he will be NATed to the private IP,
yeah.
right? So NAT configuration is pretty straightforward. You know what to do.
Yeah.
You
Public to
put your
private IP.
public to private, right? NAT wise, no confusions. But with respect to your, since it's a destination NAT, with respect to the security policy, the firewall expects you to write the security policy in such a way that your source is understood. So it's coming from untrust. Your user is from untrust, and the IP address would be any because you don't know who is accessing it.
Mm,
And the destination is again untrust because you're going to reference the public IP. But if it is a destination specific NAT, the traffic security policy is written for a destination NAT traffic. The destination section of security policy is expected to be written in such a way that you got to write your pre-NAT IP and post-NAT zone as your destination.
yeah.
So
Postnet is to define the exit interface, that the zone for reaching the server.
yeah, exactly. So this is your destination side of your security policy. Your source, as I said, it's going to be any IP address would be any, and the zone would be untrust for your
Mm,
source, right? For your destination, you got to write it in such a way that your IP address would be pre-NAT IP, which is nothing but your public IP, destination public IP of your server, and post-NAT zone. So after your public IP gets NATed to private IP, what's the corresponding zone for the private IP? That should be your destination zone for the security policy. So because you are changing your destination zone and interface, if you're changing the zone, you're basically changing the interface also, right? Interface is directly mapped to a zone,
mm, yeah.
right? So because you're changing the zone here and the IP address in a way that firewall can understand, you got to do your egress interface check again. So that's what it says here. So if the destination NAT is present on the match true, do a second forwarding lookup to get the final egress interface or zone, because your interface or zone with respect to the example changes because of this type of the security policy that you're writing. So because of this, you got to do your second check. The firewall will do the second check to forward to check the routing table to get the final egress interface or zone. Yeah.
That is to
Only
reach
if
the
it is a
server.
destination. Yeah. Only if it is a destination NATed traffic.
Okay. So here one more thing is that when the traffic gets reach the server and when it's processed, there should be a source NAT happening on the firewall, right? To send traffic back to the user.
Sorry, can you come again?
We would be need to do the source NAT, right? When the traffic goes to the internet, the firewall should be able to have a source IP as a public IP, right?
Well, you're talking about the same traffic?
Yeah, same traffic. So here we are doing post NAT and it's reaching the server.
Okay.
And reaching server, and the server processes the traffic and it returns to the user. So when it returns to user, it reaches the firewall. The firewall needs to convert the internal IP, sorry, the private IP to a public IP so that it goes to the internet and reaches the user, right? So
Exactly.
there should be a source NAT defined also, right?
For the return traffic?
Yeah,
So
return
source
traffic.
NAT, you mean when the traffic is responded, when the response traffic from the server happens towards this user. So this user is an unknown user. You are
Yes,
getting that, right? He's not a
exactly.
corporate user. He's an internet-facing user.
So when it
And,
reaches, when the traffic reaches user, the firewall should provide a public IP as a source IP, right?
yeah, so that happens automatically. So let's talk about what is your forward traffic and what is your reverse traffic. So if you consider this direction of the traffic is your forward traffic.
Forward.
Yeah. So as I said, you were not present yesterday, is it?
I was present yesterday.
So yesterday we were talking about something called a stateful inspection, right?
Yes.
Yeah. So stateful inspection means what? If there is a traffic which is sent from in this direction, the same example, a user from outside, he is accessing a server from your DMZ zone inside your corporate network through the firewall. There is a rule that is supposed to be there to allow the traffic in the forwarding direction, the forward direction. The return traffic is automatically allowed by the firewall,
Oh,
right? So that's what you call it as a stateful inspection. So firewall will keep track of all the sessions. If the user from outside is accessing the server, he will keep track of the session, what is the NAT happening, everything will be taken care. It will have a track of what is exactly happening in the forward direction, so that when the return traffic comes back, it is going to allow that by default. So you don't really need to have any policy with respect to the return traffic for the firewall to process it. It could be a NAT policy or a security policy. You don't really need to have anything, because the firewall keeps track of what is the source IP, what's the destination IP, what's the protocol, port number, application, and whether the source or destination is NATed or not. So since it has a track of everything, when the return traffic comes back, it knows that it should retranslate the private to public IP.
okay.
Yeah, you don't really need to have a policy there for the return traffic, because the firewall is stateful. It will take care of that automatically. The
Okay.
return traffic is not required to have a policy.
Yeah. Since it's DMC, I had a doubt. So the return traffic conversion, right, from private to public again. So I had a
Yeah,
doubt.
it will convert to private to public. You are right. The private IP to public IP is supposed to, because or else the flow itself will be broken, right? So your PC
Asymmetric, it will get dropped.
exactly. Your PC will not accept the return traffic if it is coming from a different IP, because it is sending it to a public IP. If it is receiving from a different private IP, it will say, I have sent the traffic to this specific public IP. I'm getting a response back from some other IP. So the state of the packet is broken now. So I'm going to discard it. The PC itself will discard the packet. Yeah, definitely the private to public IP translation will happen, but it will happen automatically. You don't
Okay.
really need to have a policy.
Got it.
Yeah. Okay, so any other questions with respect to the packet flow? So I thought of keeping this agenda pretty simple today, because this part of the discussion is very important. So I thought I would spend the whole 1 hour on the same topic and take questions more than rather than going for another topic and then finishing them in 1 hour. So if you guys have any questions, we can take it. If not, I will probably show you a short lab with respect to how do you configure or commit a change. With respect to how do you commit a change on a firewall, we can probably see how things work at there. So do you have any questions on this, or shall I move forward? Anything to be repeated?
Uh,
Okay, considering I'm assuming everything is good, everyone are okay. So let me quickly log into the lab. I should have logged into the lab already because the firewall would take some time to bring itself up.
Your screen is off as of now, sir.
Yeah, I get that. I'm just logging into the lab. Just give me one moment. Okay, I'm in. Give me a second to share my screen again. Okay, so for those who have not attended the session yesterday, as I mentioned, we were talking about um, the firewall and how do you configure the management interface of the firewall. So with respect to the management interface, we have logged into your firewall. Just double clicking your device. If you're not familiar with PNet Lab or EVNG, just double clicking on the device will take you to the console of the device. So just for accessing the firewall through GUI, I have provided another PC or provisioned another PC. Yes. Any questions?
Hi, Azad. This is Jignesh.
Hi. Yes. Yes, Jignesh.
So I had a question. Like in morning, I was trying to open this uh, Palo Alto on Peanut Lab, but however, I'm getting a boot up error.
Boot up error.
Yep. So it's not going through uh, on like it's getting like hit any key to stop auto boot.
Okay, so make sure that your RAM is properly configured with 4 gig and your CPU is 2, and also make sure your QEMU version is 131 and not something else. So please take care of these three, and I think it should work. If you have logged into your lab now, just try to check these three parameters. Your RAM should be sufficient enough, 4 gig minimum, and your CPU should be 2, and then your QEMU version should be 131. And
Okay.
I think if that is, and then also your version should be 10114H9. If you have other versions to choose from, make sure you're choosing this. For me, I have only one, so this is a work. This is sort of a stable version, I would say, with Peanut. So make sure that you use this version, and your RAM and CPU is taken care with your QEMU version, which is 131. So this should probably fix your problem. If you can check this in the session and let me know. I can try to verify yours, or else you can contact the team who provided you the access. They should definitely be able to help you.
Sure, thank you.
No
Yes,
worries.
sir. With the QEMU version 131, it's working perfectly. Yeah.
Oh, okay, all right. Yeah, there you go. So it's only the QEMU version you should take care. I think it should be fine. And so with respect to this lab, as you might have already heard from me, that your Palo Alto on your Peanut Lab or EVNG will take about 20 to 25 minutes to power on, or at least 15 minutes. So if you see, I've already got my login prompt, but my login will not work. How much ever times I type in the right password, it's going to show login incorrect. The reason being, it's going to do some backend daemon processing, which will take about 15-20 minutes. So I sort of forgot to power this on while I was talking to you guys. So because of which we probably need to wait for some time. Meanwhile, I'm just going to talk about what we did yesterday as part of our lab or demonstration. I'll be just using this board to write things down so that people who have not attended yesterday are aware, and also it will be a recall for people who have attended as well. All right, so while this is powered on, so we have discussed a few basic stuffs on Palo Alto, not too technical, but some good to know information. So where we said your firewall out of the box, the brand new firewall is going to have a default IP address of 192.168.1.1, right? So this is going to be your /24. This is going to be your IP address and subnet mask for your firewall by default, and your default username and password on your firewall will be admin and admin. So this is something that you should change on your first login. It will prompt you to change the password. If not, it's not going to let you in, right? So this is your default IP address and your default username and password. But for this lab, I think I do not see this IP address available. So I have statically configured this on the firewall, for which we have to go on to config mode, which will be configure. And once you're on config mode, from your prompt to this, it changes to your hash prompt. So when you're here, you know that you're on config mode, right? So the command is going to be set device config system IP-address, and then the IP address, whatever is the IP address you want to configure, net mask, and your subnet mask here. So since in my example here, I don't really need a gateway because I have a directly connected PC, which I will be configuring with the same network IP address. If I have 192.168.1.1/24 on my firewall management interface, I will configure maybe .2 on my PC with the same subnet mask so that they both can communicate with each other. I don't really need a gateway, right? So in your uh, production network, you might be sitting in some other location and you might be accessing the firewall remotely. So in that case, your network is different and your firewall network is different. So you should obviously need a default gateway or a gateway IP address for you to get your firewall's management and IP reachable, right? So in that case, you really need to configure a gateway. So for which the command would be gateway and then your IP address of the gateway. So once you do this and hit enter, you will assume that the config will take effect. But with Palo Alto, it is not going to. As we said, we have to commit the changes, right? So the command is commit, right? More often than not, we will be using GUI but not CLI for configuration. But there are some cases or scenarios where you would need CLI more often than not for troubleshooting, if not for configuration, right? So I forgot to tell you one more thing where before you configure the IP address, you need to change the mode of your interface. By default, your management interface is of DHCP. You got to change it to static mode before you configure a static IP, right? So that's again one more step that you need to do. So that's about configuring the management interface. Once it's done, we have configured the IP address of your firewall of your PC on the same network as your firewall, and then access the firewall through GUI through your web browser. Like, okay, and then we tried to go through some basic uh, information about what are the different tabs that you have on the firewall and why is it used for, what's the significance of it. Right, so that was your day one. So I hope the login works now. Yeah, it works now. All right, so all good. So let's try to log into the firewall through my PC. So these configs are already done. So my firewall is already going to have 192.168.1.1 IP, and my PC is having 1.2, if I'm not wrong. All right, so for us to access the firewall, we have to go to our Chrome browser, access them using the IP address. I hope it is 1.1. So 192.168, 1.1. So I've already changed the password. As I said, on your first login, the firewall will ask you to change the password, which I have already done. So I should be able to log into the device now without any hiccups. So let's just wait for it. Yeah, the device is logging in now. So even if you have two CPUs, there is certain lag here, but I hope two should be sufficient for for our labs because we need to have other resources for your Windows server. If you want to have one more PC or switch or router, you need to have other resources allocated to those devices. So try not to give more resources for your management interface, management PC and the firewall itself. Then you will be running short of resources for the devices. Okay, so we have yesterday discussed about all the tabs that you see here. Never mind if you have missed it yesterday, but it's a good to know information that we discussed. But we will probably talk about doing any change and committing the changes. So we'll just talk about the whole point of committing and why it is required and what do you really need to know about it. So let's try to do some changes. So I'm not going to talk about anything technical here. I'm just doing anything that would be considered as a change on the firewall, right? So let's say I'm just creating an address object. So I'm just saying I'm giving a name. I'm just giving a name as test, and I'm just trying to configure an IP address. So I'm just trying to use this object. So object is basically necessary for you to name an IP. For example, if this is an IP address of your computer, and if you want to allow a traffic from your computer to anywhere outside your network or to a server, you can configure this as an object called test, and you can use this test in your policy and say source is test and destination is the server IP, and it is allowed. So the object is basically used for defining an IP address or a network or an FQDN or whatever it is. So I'm just doing a change simply on the firewall. And as soon as you do this, the commit will be active. So I can click on commit. And there are two ways of committing the change. One is commit all changes, which is going to commit everything that every administrator is doing currently on the firewall. So let's say there are 5 people in your team, all of them works on a firewall every day, and all 5 of them are currently doing changes on the firewall. And if you are saying commit all changes, it means that you're trying to commit the changes done by every one of your team member at this point of time. So there may be a chance that one of your team member is in the middle of a change and he has completed halfway. Let's say he has configured the interface IP address, but he has not configured routing, which he was trying to do so, but before which you have committed all changes, and it was an incomplete configuration from his side. And since you have committed his change, things will go, things might go bad, right? So you might lose access to the firewall. You don't know what configuration was missing. You will also be left at sea because you don't know what's going on. So you got to always make sure you commit your changes, only your changes, not all the changes anytime. So make sure you're committing only the change of from your administrator account. So I've logged in as admin, and this is the only change that I did. So you have to always make sure that you're doing a commit on your change alone, not on all the changes. So that's one good thing to know. And the scope, I have done the changes on policies objects and device and network. So I am not sure why it is showing this. So if you're not aware of why it is showing, see, I have configured only one object right now, which is under objects. So it's relevant if I see the commit scope to be policies and objects because I know I've done a change. But why is it showing a device and a network is also being changed, which is nothing but these two tabs. Either of these two tabs, according to this commit scope, it says either of these two tabs also have gone into a change. I don't really have an idea if I have done any change yesterday, because if I've done a change and I've not committed, I have powered off the firewall yesterday and I'm powering it on only today while we are discussing it. So there is no way that I've done any change after I logged into the firewall today. So there is an option for us to review what we have done before we commit the change, right? So remember, when you do a change on the firewall without committing, it's not going to take effect like Cisco or Fortinet, right? If you worked on any of these two devices, you know that as soon as the IP address will take effect. But with Palo Alto, it is not going to be the case. You are supposed to commit the change, only then your changes will be having any relevance. So since we have not committed, the change that we did, the configuration that we just did by creating an object is not going to be applicable to the firewall because it's still a draft before committing. So let's try to preview the change, and let's say we are going to be ask them to list 20 lines of content. So you see that this is the running config and this is the candidate configuration. So what is the difference? The running config is the configuration which is a committed configuration. Candidate config is the configuration which is outstanding, which is not committed. So basically whatever changes we have done here right now will be displaying as candidate configuration, but not on the running configuration side because we have not yet committed the change. So the object that we created should show up here. So if you see, okay, this was device telemetry configuration, which is something that we did not do, but it usually picks it up with respect to where we are located automatically. So this is not something that we did. This is the reason why we were seeing that there was some change made on device and um network and device tab, yeah, under the commit scope. So as you see, my change of address object of test is created here. So when you see a green font, it it defines that you have added something or created something. And if it's in yellow background, you know that it is something that you have edited from the existing configuration. And if it is red, then it means you have deleted something. So you have created an object, right? So that's exactly what you've done. So you can verify what exactly you are going to commit as a change. So if I just say commit all changes, if you do preview changes under commit all changes, it's going to show every change done by every other administrator of yours. So that's not something that you want to commit. So make sure you're committing only your change. And to be cautious enough, you can preview the changes each and every time you commit, until at least you get comfortable with, right? Change summary, pretty much the same. So it will just display it in a different format as to what the change is about. So if you see, if I click on the object name test, it's saying what have I configured exactly, right? Device telemetry again, it's going to say what exactly has been configured, right? So before you commit the change, you can also validate and see if the commit will indeed be successful. So if I say validate commit, it will validate the result of your commit and it will say whether the commit would be successful or not. So it's queued now. So it will validate and then it will identify and let us know if I hit a commit button, will it be successful or not, right? Instead of not directly committing it, you can basically validate it and see if the commit will be successful or if it will get any error thrown by the firewall, right? Accordingly, you can edit before committing rather than committing them directly and then getting an error. So that's also an option, right?
Yeah.
So let's just wait for this to complete. And then finally we can commit our change. So that's all the information you need to know about commit. Because this is something very important and critical because this is where whole of your change lies, whether it's going to be put into the firewall or we're going to delete the changes that you're doing.
Regarding the change summary, right?
Mhm.
So normally when we see the other tab, if there's another option, right, to show what is added or modified, that provides a clear clarity. And the what's the difference where the change summary and the other tab?
It's just another way of looking at things. So, it's just when I am, so see, if you see change summary, it is a tabular column which will give you exactly what you've changed,
Okay.
right? So, for example, okay, let me close this. The validate is completed. If you see it's successful, and there is no errors, so configuration is valid, right? So now it's safe to commit the change now because the validation is complete. So I can click on commit, but before which your question was preview change.
Preview changes and change summary.
So this is going to give you the exact XML format of your configuration. It is going to throw everything at you, and not only the configuration you did. You see, you were having extra additional information about something that you have not configured currently, right?
Mm.
So let me give it
And
some.
you mentioned the telemetric recording with
No,
that
no,
one.
not that one. But if you see preview changes, it's gonna give you, see, you have only configured, okay, let's say you have done the device telemetry also, device telemetry and the object configuration. That's all the two changes you did. But when you say preview changes, it was giving you the whole running configuration,
Okay.
including the other configuration also. So if you see, there are other stuffs also over here, right?
Okay.
But your summary is only going to say what exactly you have done. So that could be that is the only difference. So if you see, this is the test object you have created and device telemetry change, which was automatically available as a change. So these are the only two changes you have. And it will say if who was the owner who has done the change and what was the change about. Is it a create or a edit? And will it be committed? If it's part of the commit scope or not, it will say yes or no. Right? So finally, if I
Yeah,
just
got it.
hit commit, it is going to do the checks and then it is going to commit the change because the validate was complete and it was successful, and hence the commit will also be successful. There is no reason for the commit to go unsuccessful right now because we have already validated it. All right.
Yes, sir.
Do we have any option to take the log of admins?
I didn't get your question. What exact log you are referring to?
If I just to consider if we have a 3-4 admins, so I want to take the logs, what admins make changes in the firewall.
So with respect to that, you have something called as config logs here, right? So this will give you who is the administrator who has done what changes. You see, the commit was done by administrator and the set, that is the address object of test, is created by the admin at what time.
Okay, and is it possible to get a detailed report? But here we cannot identify, right, what he exactly did.
Yeah, so you could go to your monitor tab
Okay.
and try to create a report here. So you could try to play with it to see how you could exactly create a configuration report. So for example, so basically you won't track that here. Rather, you would have your login integrated with your Active Directory. Like you will not have a local username and password configured on your firewall, but rather you will have AD integrated with your username and password. Your Active Directory will basically be collecting all the logs and it will be sending it to um, the syslog server or whatever it is. So that's where you probably might be uh, doing all this log collection, right? Not basically over here, but onto your syslog server from your Active Directory.
Okay.
So if you want to generate a report, it should probably be over here under Monitor tab. But for you to view what exactly and who has configured it, you probably can do that here under your config logs. But with respect to exact report creation, I probably will do a research and let you know. It should be somewhere here that you can manage custom reports. Let me see if I can add something here and then give you the answer. So you have you do not have anything with respect to your username or user activity. No, I don't think you have it here. You probably should have a database that should be collected for your config logs also, but looks like it is not available here. So I'll give you an answer in the next session probably.
Okay, thank you.
Yeah. Yes, guys, that's about today's session. I hope it was informative, and I would like to encourage you to see you all in the upcoming session. Probably starts on Sunday. You will get intimated about it later from the faculty. Sachin, I'm done with my content for today, my agenda for today. You can take it over.
Yes, sure, sir. Thank you for the information today, and I believe you all guys enjoyed the session today. And if you have any question, you guys can ask so that we can sum up for today. Anyone like available in the session? Chandan, Debajit,
I think
Jignesh.
it's all our good sessions.
Yeah, thank you, Rohit. So, okay, sir. Thank you for the day today, and good night, everyone. We will, meet by tomorrow, or I will update regarding this further schedule. Whoever wants to like take the admission, they can connect with the counseling team, and we have an offer is also going on the firewall combo Palo Alto and Fortinet, so you can reach out to the admission team. Thank you, guys. Good night. Thank you, sir.
Thank you.
Thank you,
Thanks,
thank
Thank you, sir.
everyone. Yeah, bye-bye.
So for the yesterday recording is still not uploaded on the portal. So when will be upload, like once the
It
session is
it
complete?
has been uploaded, Jignesh. I'll guide you where you can find that. Don't worry.
Sure, thank you.
Thank you.
Sir, I have one question.
Yeah, please, Nivedita,
Yeah,
you can
hello.
ask.
Yeah, see, as I said that as means I like to know that where we are talking about this.
Mm-hmm.
Just 1 second. Means how it will relate to the Microsoft Sentinel this network. Means yeah.
Yeah, I would like to add Mr. Azad here. Azad sir, you can like answer this question. So
Yeah,
that will be better.
Nivedita, can you please elaborate your question as to what exactly it is about?
See, now we are learning this Palo Alto, right? So how I will configure this Palo Alto to my Microsoft Sentinel thing. So means yeah.
So Microsoft Central, I would like to know more about what exact tool you're talking about.
Oh, okay. This is about the cloud thing, right? So data injection will be happen from this, and there is a. So I need to configure with this and that. This
So
firewall.
Microsoft Central is basically uh, a log collection tool, if I'm not wrong.
Yeah, true.
Yeah, so basically it is something that you will be not interacting directly with the firewall, but rather whatever the firewall can give as an input, with respect to the log or the threat detection or whatever it is, you could take that to the syslog server. So you will have a permission from your firewall to integrate it with the syslog, and the syslog server will have all the logs collected, and from there you could fetch the logs for your Microsoft Central, and then do whatever you would like to do with the logs. So it's basically something that you can I mean, if you're putting a lot of a burden on your firewall for doing all the processing with respect to interaction with your central Microsoft Central or whatever it is, then your firewall might not be able to do the actual processing of the firewalling that it's supposed to do. So you will be offloading other stuffs like log forwarding and other stuffs to the actual syslog server or whatever server is applicable. From there, you can take the logs onto your tool and then start working with it.
Okay. Okay.
Yeah.
Okay, sir.
And one more thing, Nivedita, this firewall will help you to get more growth into the cloud security as well. Yeah.
Which one? This. Okay.
Yeah.
This Palo
Okay,
Alto,
guys.
right?
Yeah. Thank you, guys. Thank you for the day today. Thank you.
Okay. Thank
Yeah.
you, sir.
Thanks, everyone. Take
Bye.
care and see you tomorrow.